Hello guys, hope you are doing well. In a new session, we will be talking about the last section of chapter 6, which is all about the solubility equilibrium or the solubility product KSP. We will be calculating the values of KSP through the concentration of the ions of ionic solids, and we will be solving the concentration of the ions through the KSP values, and at the end of the section we will be able to determine the precipitation calculations and to predict whether mixing of two solutions will form a precipitate or not. Guys, the solubility equilibrium, we talked about the equilibrium and shifting equilibrium in the previous sessions. The solubility equilibrium, it talks about when an ionic solid dissolve. This is the dissolution process in the forward dissolution process and the reverse crystallization process. In the dissolution and crystallization, when the rate is of the crystallization of ions when they combine to form the ionic solid equals to the rate of the dissolution of the ionic solid to form the ions, this we call as the equilibrium and the solubility equilibrium, guys. As I told you guys, when an ionic solid dissolves in water until they are in equilibrium with their ions, such as aluminum hydroxide. In this case, guys, the aluminum hydroxide dissolved to form aluminum and hydroxide, and then there will be possibility for aluminum and hydroxide to back to form aluminum hydroxide. If the rate of these two directions are equal, so there will be solubility equilibrium, and the equilibrium state will be reached for an ionic solid when it dissolves. Concentration of the ions can be determined from the balanced chemical equation and solubility data. Guys, from the balanced equations we can determine the concentration of the ions or the solubility data. There will be sometime provide the solubility tendency of the ionic solids. Through their solubilities, we will be able to determine the concentration of the ions. As the concentration of ions are known, the ion concentration can then be used to determine the equilibrium constant we call as KSP. We will be explaining the meaning of KSP and we will be calculating mathematically as well. So we use the solubility data to calculate the concentration of the ions. And as the concentration of the ions are known, we'll be able to calculate KSP, which is the constant solubility product. We will explain in detail, guys. And what's the KSP's application, guys? The numerical value for equilibrium constant can be used to predict whether precipitation occurs when solutions of various concentrations are combined. Later on, we will use KSP to determine when we mix two solutions together, whether it will form precipitate or not through the KSP value. That's the application of KSP. So, guys, let us talk about the solubility product. The solubility product in this section, guys, we will be talking about and we will deal about with the solutions which are saturated solution. So a saturated solution is what? Is a solution that contains the maximum amount of solute possible at a given temperature in equilibrium with an undissolved excess of the substance. We have two terms of saturated, unsaturated, with dilute and concentrated. The saturated and unsaturated refers to the limit of solubility of the ionic solids. If the solubility of the salt reaches to a point that the salt addition of more salts precipitates or settle out at the bottom of the container without dissolution, that will be the saturated solution. No more solid that can be dissolved to form ions. But the terms of concentrated and saturated, concentrated and dilute, we mean a concentrated high amount of solute in the solution, and the dilute low amount of solute in the solution. The concentration may be high concentrated or low dilute, depending on the solubility of the solute. Sometimes the solute does not dissolve, its degree of solubility is low, does not form a concentrated solution, is dilute, but still reaches to the position of saturation. Sometimes with the high concentration of the solute, it reaches to the saturation point. And for that, the solutions which are saturated can be dilute and concentrated regardless to the existence of the solute in the solution. In order to call those ionic solids that we deal with are soluble, insoluble, and slightly soluble, we have three ranges of their solubility. If the solubility is greater than 1 gram of the salt per 100 grams of water, we call the salt as soluble. If it is less than 0.1 per 100 grams of water, we call as the insoluble. If it is in the range of 0.1 to 1 gram, we call as the slightly or sparingly soluble salts. Guys, in this section, we'll apply equilibrium principle to all saturated solutions which are sparingly soluble. And guys, the sparingly soluble salts with the low tendency of solubility, they reach to the saturation point. Usually those salts that they are highly soluble, the saturation requires more time than the salts which are sparingly soluble salts. We said we are dealing with the sparingly soluble salts because the sparingly soluble salts, we have to know the degree of solubility of their salts. But it's not the meaning that we cannot determine the KSP solubility product for the soluble salts. Yes, we are, but because of existing a high amount of concentration of ions, you will get a more high value of the KSP, and then the high value of KSP represents the highly solubility salts, but the low value of KSP, which for sparingly soluble salt, we will be dealing with the sparingly soluble salts. And guys, how to know which are the sparingly soluble salts? For the table 1, in chapter 1, section 1, we talked about the table of solubility, the solubility guidelines. All the salts there, which we call as the insoluble, here we call as the sparingly soluble. An example is what? Is like AgCl. AgCl, we called in the table of solubility as insoluble, but here it's what? It's a sparingly soluble salt, and it forms the Ag and Cl. We will be talking about it in the equilibrium position of the sparingly soluble salts. When they reach to equilibrium and they form a saturated solution, what will be the maximum tendency of that salt to form ions? What's the solubility product, or KSP? KSP, we'll be talking about the meaning and application, and then mathematically how to calculate it. Guys, the meaning of KSP means the maximum tendency or the highest tendency of a salt to dissolve and form ions till it reaches to the saturation point. The application can be used to determine whether we mix several reactions or two solutions or salts together, whether there will be a precipitate or not. We'll be talking about that at the end of the section. When we compare the KSP with the IP, we will be able to calculate whether a precipitate will, or predict whether a precipitate will occur or not. Mathematically, KSP equals what? Or we can write the KSP equation by what? By taking the concentration of the ions raised to their powers. How to write? Let us provide some examples. AgCl forms Ag and Cl. How to write the KSP equation for AgCl? By multiplication the concentration of the ions. In KSP equation, we do not include the salts, the reactant site into what? Into the equation. Another one, aluminum chloride produces aluminum plus 3Cl. Aluminum and chloride Q raised to the power which equals to the coefficient, guys. Here Ca plus 2OH, Ca concentration multiply hydroxide square. Why? Because the coefficient is 2. So, how mathematically write the equation for the KSP? Multiplication of the ions raised to the power which is equal to the coefficient of the ions. Let us solve this example, guys. AgCl, the mass is given with the mass of water, and then the molar mass of AgCl is given as well. First of all, you have to write the equation of dissociation for the salt. This is the first step. Balance, and then take or write the equation for the KSP. KSP equals the concentration of the ions, multiplication of the concentration of ions. How to calculate the concentration of the ions, guys? The mass is given, divide by the molar mass, you get the mole. So you divide the mass by the molar mass, you get the mole. The mole, molarity is equal to mole per volume in liter. How many liter of the ester is given? 100 grams. 100 grams is equal to 0.1 kilogram. 0.1 kilogram. And guys, for water, the liter, the volume and the mass are equal. 1 liter is equal to 1 kilogram. So we can say 0.1 liter. Here we have 0.1 liter. Divide the mole by this volume, you get the molarity, the concentration. As the concentrations are known, multiply the concentrations, you get the KSP for the solution or for the salt. A sample problem is given here, guys. For copper 1 chloride, 100 or 1.08 10 to the power minus 2 grams per 100 grams of H2O. The molar mass is given as well. How to solve? 1.08 multiplied 10 to the power minus 2. Okay. This divide by 99, you'll get the mole. Here is solved, guys. And then the same volume is given. Divide the mole by the volume, you'll get the concentration. As the concentration is known, KSP equation equals concentration of copper multiplies Cl. So multiply the concentrations, you'll get the KSP. If KSP is unknown, how to calculate KSP? First, by using the solubility values, find mole and molarity. You have to use the solubility data, how many grams per 100 grams of water dissolved, convert that solubility data into the mole and molarity concentration, mole, and then we'll convert the mole to molarity. Write balanced solubility equilibrium reaction for insoluble salt. You have to write the dissociation equation and then balance it, and then write the equation for the KSP. The KSP, you have to multiply the coefficient by the concentration of the ion and then raise to the power as well. Raise to the power as well. Let us solve for the another practice. Here we have PbCl2. Guys, PbCl2 will produce Pb and 2Cl. What's given about PbCl2? The solubility data is given. 1 gram per 100 grams of H2O, and molar mass is given as well. Divide the mass per molar mass, you get the mole. Okay? And then the volume is given as well. Divide the mole by the volume, you get the molarity, the concentration. This concentration is the concentration for 1 mole of ion. How about if there is 2, 3, 4, 5? You have to multiply the coefficient by that ion and then raise to the power as well. That's the technique. Do not forget to multiply and raise to the power. Here we have got 3.60 to the power minus 2, but for Cl, as it has 2 coefficients, 2 multiply 3.60 to the power minus 2. As you can see, we multiply the concentration by the coefficient and raise it to the power as well. So don't forget, when you want to calculate KSP, multiply the concentration by the coefficient and raise to the power as well. Here the table for solubility product constant is given at specific temperature. The KSP changes with temperature, of course, as the other constants it changes with temperature. Another question, 5 grams of Ag2SO4 is given for 1 liter of water. Calculate the solubility product constant KSP. Molar mass is given. Divide the mass by the molar mass, you'll get the mole, and the mole by 1 liter, you'll get the concentration. Concentration is given for each ion, so here we do not have the coefficient for sulfate is 1, but coefficient for Ag is 2. You have to multiply by 2 and raise to the power of 2 as well. Multiply by 2 and raise to the power in order to get the KSP for the salt. Calculating the solubility by using KSP. Here we will be solving the reverse procedure, guys. We have solved the KSP when the solubility data are given. Here we will be solving the concentration of the ions or the solubility of the salts by using KSP. How to do that, guys? As usual, we write the KSP equals the concentration of the ions, multiplication of the ions. But as we do not have here the concentration of the ions, instead of the concentrations, we write a variable to represent that they are unknown. This variable can be x multiply x. X multiply x is equal to x squared. KSP is equal to x squared. So KSP is given the value 5.1 to the power minus 9 x squared. Take the square root for the KSP, you get x. X represents 3 quantities: solubility of the salt, concentration of the ions, concentration CO3 two negatives, concentration of the ions. So this X equals the concentration of BaCO3 and solubility of BaCO3 as well. Sample problem, let us solve another sample problem, guys. The KSP for AgBr is given. Write the solubility, the equation for AgBr will produce Ag plus Br. X multiply X will be X squared. Take the square root for that, you'll get the value of X, and X is equal to the solubility of this salt, concentration of Ag, concentration of Br as well. The next practice, guys, CDS is given the solubility 8 to the power minus 27. X instead of CD, X instead of S, so it will be X squared. Take the square root for this value, you'll get the X. X is equal to the solubility of CDS the concentration of Cd and concentration of of S ion as well. The same procedure, guys, another practice. Guys, let me show you how if the coefficients are not 1. Here we have got an example of Al2SO4 by 3 will produce 2 Al positive 3 plus 3SO4 2 negatives. Suppose this is the equation. Despite of aluminum sulfate is soluble, but we can write the equation of KSP. Why? Because the KSP we can calculate for soluble salts as the sparingly soluble salts, but the values of the KSP for soluble salts is too much. That's why we do not use the KSP for solving the degree of solubility of soluble salts. But theoretically, I will show you how to do this procedure, guys. If you want to write the KSP, if the KSP is required or given and find the X, guys, KSP for this is here we have got X, 2X and 3X. KSP is equal to 2X squared, 3X cube in this case. 2X squared is equal to 4X squared multiply 3 cube is equal to 27X cube. 27 multiply 4 is equal to 108X to the power of 5. And then KSP is equal to 108X to the power of 5. In this case, if you want to find X is equal to the root of 5 of KSP over 108. That will be the procedure how we can solve if the coefficients are not 1. Guys, let us talk about the precipitation calculation. In precipitation calculation, we will be talking about comparing two values of two quantities. One, the KSP, which represents the highest tendency of a salt to dissolve and form ions. The other is QSP, which is the IP. And the IP represent ion product, represent what? Represent the existence of concentration of ions in a solution. The existence of the ions in a solution can be not high to reach to the saturation, we call as unsaturated, can be equal to the IP, which saturated, and exceed the limit of the saturation, it becomes a supersaturated. So we will compare the IP or QSP with the KSP. If the IP is lower than the KSP, means the existence of the ion is not high enough to reach to the limit of saturation. That will be what there will not be a precipitate. A precipitate will not occur if IP, which the existence of the ion is more than the saturation limit, will be a precipitate. The first one we call as unsaturated. The second one as supersaturated. And a precipitate, if they are equal, becomes saturated, and there will not be a precipitate as well. Here we have got a note, guys, said equilibrium condition does not require that the two ion concentration be equal. Still, it's in equilibrium if the product of ion concentration QSP and equal to the KSP, guys. As here we have represented the concentrations of the ions is given, and we have calculated KSP, and the concentration of the ions here different than the above. We have got the value of QSP the same, and seeing the KSP and QSP are equal, it stay in the equilibrium, and equilibrium does not change. Guys, let us solve a practice and check whether a precipitate will occur or not. Usually the types of the problems in the form of mixing two solutions to form the third. Whenever there will be such questions, I will be solving one and you'll learn how to solve for the others, guys. The sample problem, here we have got a solution of BaCl2, the first solution, and the second solution of NaSO4, Na2SO4, and we mix these two to form the solution of BaSO4 plus NaCl. First, let me show you how to write the IP, guys. In IP, just raise the coefficient, raise it to the power. We do not multiply the concentration to the coefficients. For example, if we have Al2SO4 by 3 to produce 2Al positive 3 plus 3PO4, 3SO4, sorry, negative 2, the IP for this equals the concentration of Al square, concentration of SO4 square as well, cube, sorry. But the KSP equals 2 multiply concentration of Al square, 3 multiply concentration of SO4 cube. In IP, we multiply the ion and raise to the power. In KSP, sorry. In KSP, we multiply the concentration to the coefficient and raise to the power. But in IP, we just raise to the power. The coefficient becomes the power, does not become the value that we multiply the concentrations by it. Guys, for solving these questions, we use the technique of MV equals MV. MV of one of the solution equals MV of the other. We'll be able to calculate the molarity of the unknown, the ion in the solution, which its molarity is unknown. Guys, the solution 1, 2, and solution 3. What's known about solution 1? M1 is known, the concentration. V1 is known as well, volume. What's known about the second? M2 is known, molarity. V2 is known. So usually this will be the procedure. The first and the second, they have known concentration and volume. The third, when we mix them, we'll get the volume is known, but the concentration is unknown. When we mix these two, there will be formation of two salts. Calculate the IP for which of them, the one that's sparingly soluble or insoluble, we call it in the table of solubility as insoluble. For example here, guys, NaCl is soluble, so we do not calculate the IP for NaCl. We calculate the IP for what? For BaSO4. BaSO4, which we call it as insoluble. How to write the equation? Dissociate the insoluble salt to its ions, write the equation of the IP or QSP, concentration of Ba multiply SO4. Concentration of Ba and multiply SO4 must be calculated in the third solution. How to calculate that? To calculate, guys, the Ba exists in the first and the third. So take the relation MV of 1 equals MV of the third. To calculate the sulfate, take the relation between the second and the third. MV of the second, MV of the third must be equal. So let us do the procedure. Let me show you how to do that. M1V1 equals M3V3 to calculate concentration of Ba. Here the M1 is given 0.01, V1 20, M3 is unknown, V3 is known, the total the summation of the V1 and V2. Concentration of Ba is known. To calculate sulfate, take the relation between third and second. M2 is known, which is 0.05, V2 is known 20, V3 is known 40, and MSO4 we have calculated. Sulfate and barium we calculated their concentrations, so multiply them, you'll get the IP. IP 10 to the power minus 5, here 10 to the power minus 10. IP is higher than KSP, so there will be a precipitate. If IP lower than KSP, we will say it's not a precipitate, there will not be a precipitate. The same question, guys, the same strategy. I will be solving one more question here in order to show you the difference in the coefficients. Here, PbNO3 by 2 and the KCl, we mix them, form PbCl2 plus KNO3. Which one is the one that's soluble? This one. The insoluble one is PbCl2. So write what? The dissociation equation for the insoluble one and the IP equation as well equals the concentration of Pb multiplied Cl squared. To find the concentration of Pb and Cl, the Pb is in between 1 and 3rd, the Cl is between 2nd and 3rd. So take the M1V1, M3V3 to find molarity of Pb, M2V2, V3, M3 to find the molarity of Cl. This is the concentration of Pb, concentration of Cl, but square because its coefficient is 2. We calculated QSP or IP, which is 10 to the power minus 6. Here KSP 10 to the power minus 5. QSP is lower than the IP, KSP, so there will not be a precipitate. This is the table, guys. The figure 13 represents what? Represents the cases of combination of ions to form a soluble or insoluble. Guys, Ag, A and B, Ag plus nitrate, they will form a soluble salt. This is the first case. Second, Ag and Pb in the C and D, they will, when they combine with chromate, they will form what? They will form precipitate. Ag chromate and silver chromate and lead chromate, they will produce what? Precipitates. The E and F, we have thiocyanate ion, SCN negative. Thiocyanate ion, when reacts with Ag, will form an insoluble salt. But when reacts with the Fe positive 3 ion, it's what? It's soluble. That's the figure 13, which is the combinations of the ions. Here we have got a critical thinking, guys. The critical thinking said, predict which of the following precipitates, CaF2, CrF3, and LaF3, guys. In order to predict CaF2 will produce Ca positive 2 plus 2F negative, IP must be calculated. Ca positive 2 multiply F squared. How to calculate the IP? We have to calculate concentration of F and Ca. Concentration of F is given from the above, which is 1/10 to the power minus 4 squared. How to calculate concentration of Ca? CaNO3 by 2 produce Ca positive 2 plus NO3, 2NO3. Its concentration is given 0.2 molar. If 0.2 molar of this is given, this is equal to 0.2 molar of Ca. So 0.2 molar multiply 1/10 to the power minus 4. The IP is equal to 0.2 multiply 1/10 to the power of minus 4 square equals 2/10 to the power minus 9, guys. 2/10 to the power minus 9. This is the IP. Compare this IP with the KSP, which is given 3.9 10 to the power minus 11. Minus 9 is higher than minus 11. So the salt of CaF2 will be precipitated. That's the strategy to solve the critical thinking. We have got 3 salts. As the answer is what? CaF2 and LaF3 will precipitate because their IP higher than the KSP, but CrF3, the IP is lower than the KSP, that's why there will not be a precipitate. Let us solve some ministerial exam question. Guys, I will be solving the first, I will not be solving because it's we have solved it. I will be solving some ministerial exam that's new. Question 6, guys. I will be solving question 6. Question 6, we have got a solution of NaOH. Two values of this is given 100 milliliter with the 110 to the power minus 4. This is the molarity which is given. And added 2.5 10 to the power minus 2 more grams of FeNO3 by 3. Okay, guys. When we mix these two, guys, NaOH plus FeNO3 by 3, we will get what? NaNO3 plus FeOH by 3. Which one is soluble? This one. The other is insoluble. So we will calculate the IP for iron hydroxide. FeOH by 3 will produce Fe positive 3 plus OH 3OH negative. And the IP is equals concentration of Fe multiply concentration of hydroxide cube. How to calculate concentration of hydroxide and Fe? From the given data, guys. For the FeNO3 by 3 will produce Fe positive 3 plus 3NO3 negative. Mass of the iron nitrate is given, divide by the molar mass, we'll get the mole, 2.5 10 to the power of minus 2, divide by 242, this is the mole, and divide the mole by the volume 0.1 liter, guys, divide by 0.1, we'll get what? 1 10 to the power minus 3, 1 10 to the power minus 3 molar. How many molar of this is given? This is equal to the same of iron, 1 10 to the power minus 3 iron. So the iron is 1 10 to the power minus 3 concentration. And NaOH, concentration of NaOH is given. Concentration of hydroxide is the same as the concentration of NaOH, which is the 1 10 to the power of minus 4 cube. 1 10 to the power minus 4 cube is equals 1 10 to the power minus 12. 1 10 to the power minus 12 multiply 1 10 to the power minus 3 is equals the IP 1 10 to the power minus 15. Which one is true? The 1 10 to the power minus 15, A and B are correct in terms of the IP, but B is the correct one. Why? Because this is higher than the 10 to the power minus 38. That's why it will be a precipitate. Question number 7, guys. Let me solve question number 7. This is another ministerial exam question. HGS will produce Hg positive 2 plus S negative 2. Requires concentration of Hg ion. You may remember that you studied this equation. Mole is equal to number of ions or particles per Avogadro's number in grade 10. Avogadro's number is given. If we calculate the mole, we will be able to calculate the number of ions. How to calculate the mole? Through the KSP. KSP is given. KSP for this x is equal to x squared. X is equal to square root of 1.6 10 to the power minus 51. Minus 51, it will be minus 26, but let me take the 1.6 10 to the power minus 51. Oh yes, 4 10 to the power minus 26, guys. This is what? This is the concentration of Hg. The volume is given, so let us convert this concentration to mole. by multiplying to the volume is equal to this multiplied by 1000, you'll get what? 4 10 to the power of minus 23. This is the mole. And mole multiplied by the Avogadro's number, guys, which is 6 10 to the power 23. 23 and minus 23 cancel out. 6 multiplied 4, you'll get 24, which is the number of the ions of Ag. Guys, let us solve the last question, which is somehow contains new ideas. Here we have got two solutions. Solution, the first one contains PbNO3 by 2, and the second one Na2SO4. The quantities which are given about the first, which is 25 milliliter with 5 10 to the power minus 5 molarity, and the second is first and second, 25 milliliter but 4 10 to the power minus 5 molarity. When we mix these two, guys, when we mix these two into another container, suppose this is the third solution, we will get what? Two salts of NaNO3 plus PbSO4. We will not calculate for NaNO3 the IP, we just calculate for PbSO4. Why? Because PbSO4 has a possibility to be precipitate. So the third is equal to 50 milliliter, because 25 plus 25 equals 50. We will be calculating what? The PbSO4's IP, which produce Pb plus SO4 negative 2. IP for this equals concentration of Pb multiply concentration of sulfate. So let us calculate the concentration of Pb by M1V1, M3V3, which is 25 multiply 5 10 to the power of minus 5. This divide by 50 milliliter, which is equal to 2.5 10 to the power minus 5. 2.5 10 to the power minus 5. This is concentration of Pb, guys. For SO4, the second and the third, 25 multiply 4 10 to the power minus 5 divide by 50 equals 2.2 10 to the power minus 5. This is concentration of sulfate. This is multiplied by 2.5 10 to the power of minus 5 equals 5 10 to the power minus 10. This is the IP or QSP, guys. 5 10 to the power minus 10 compared to the 1.6 10 to the power minus 8, it's lower than 1.6 10 to the power minus 8. In this case, there will not be a precipitate. If there will not be a precipitate, there is no reaction and there will not be a net ionic equation. For that, we just choose the D option, which is none of them is a net ionic equation. All of the ions become a spectator. If required spectators, we will choose the ions of Pb, NO3, NaSO4. They are all spectators, guys. Let us solve for the, this is the test bank for the section 4 and the chapter review as well. We have solved the chapter review, but we will be solving the standardized test prep and then end the session, guys. The standardized test prep, we have got 7 questions almost. Let us solve the standardized test prep, guys. A chemical reaction is in equilibrium when the forward and reverse reaction has ceased. The equilibrium constant equals 1. Forward and reverse reactions are equal rates. Yes, C is the correct answer because they have equal rates. What change can cause the value of the equilibrium constant change? Of course, only temperature can change the equilibrium constant value. Consider this reaction: carbon solid with the oxygen gas, yes, with carbon monoxide gas, yes. The equilibrium constant expression equals the CO square over oxygen. A is the correct answer. We do not include carbon because it's solid. Question number 4, the solubility product is given, requires to find the concentration of the ion. It's simple, guys. Consider the following equation for the equilibrium system, which concentration represents in the denominator. Denominator means the reactant, guys. Denominator is the reactant. Numerator is the product. In the reactant we have carbon solid, we do not include. PBS we do not include, just oxygen. So D is the correct answer, which just oxygen represent in the or present in the denominator. In exothermic reaction means delta H is negative, temperature increase is positive. These two are opposite, so there will be a reverse and favor the reverse direction. B is the correct answer. The last question, question 7, Le Chatelier's principle stated that at equilibrium the forward and reverse reaction rates are equal. This is true, but not for, it's not the statement of Le Chatelier. Stress includes changing concentration, pressure, and temperature. True, but it's not the statement that Le Chatelier stated. Guys, to relieve stress, solvents and solvents are omitted from equilibrium constant expression. It's not also. Chemical equilibria respond to reduce applied stress. This is the statement of Le Chatelier, which said whenever a system at equilibrium applied to a stress, the system adjusts itself back to the new equilibrium by relieving or reducing the stress. Thank you for the attention, guys.